Alright, so in today's video, I'll be showing you how to create a floor plan using Grasshopper. So a lot of times you've probably seen people use Grasshopper for crazy stuff, but this is going to be a great tutorial for those of you who want to learn how to create more practical designs. So this is using Grasshopper to create the overall shape and size of the bedroom. We also create the overall length of it, and we're able to change all of the parameters here. So the power of this is that you can create one script that you can update and you can change just by moving the sliders, and that's the power of parametric design. Is not having one static design, is being able to change those design options within your script. So if you're interested in learning a little bit more about parametric design, I'm going over all of the steps here. This is part one, where we create the overall form, we create the doors, and later on we'll be finishing this up. So if you're excited to learn a bit more, stay tuned. If you get stuck somewhere or you go, hey, I don't know how this gets plugged in, you can always download the script as I post it on my website. When the next video comes out, I'll be updating the script. So with that being said, thank you very much for being here. Hopefully you're excited to learn a little bit more, and let's jump right into it. So today's video is going to be a little bit different, and the reason for this is I typically try to create a tutorial first and do it on my own so I can figure out all the steps and show it to you without any mistakes. Now, this particular design that we're doing today, I haven't really done it myself before. I'm just going to do it here with you for the first time. So to create this unit, what I did was I went into Google and I downloaded an image of a bedroom layout for a hotel. And so what I'm doing here is I'm dragging that in. It's going to be brought in as a picture. I'll hit OK here and then just bring it in. So we'll be creating this parametrically within Grasshopper, but like I said, there's going to be some things that I haven't figured out yet. So we're going to do it all together, and I'm going to show you the entire process here. So first, we'll bring in this picture. Then we can scale this so we can have it as a reference. Now, you can also have it on the side, but sometimes it's okay to bring this in and have it as a reference here within Rhino. It just makes it easier for you to pan around and see it. So let's go here to scale. I'll go from the center of this inside face of the wall to the inside face here, and I will scale it by what it says here. So my drawing units are inches, but I can still type in 17.6 feet. And now we basically have this scaled to the right size. Not that it really matters, because we'll be able to change some of the sizes using the parameters. So let's keep this here. And now let's get started with the overall size of the bedroom. We'll start with the basics, which is going to be creating the walls. And then we can focus on doing the openings. So let's go here and start with the first thing is we're going to give it a location of where it's going to be created. So we'll go here to construct point. I like to route this one through a point component. This way we can always change that location if we want to. Next, we're going to take this point and we need to create a rectangle. Now, there are so many different ways here within Grasshopper to create a rectangle. And you can tell because when you type in rectangle, you'll see that there's rectangle, there's rectangle 2 points, rectangle 3 points. So the way that we'll be doing it today is going to be rectangle 2 points. So starting with this origin point, we're going to now move this point to create the other corner. The thing is that the dimensions that we have here are going to be from inside to inside, and I actually want to create the design using the outside. So we'll use 18 feet for the outside X, and then we'll use, let's see, 27 feet for the Y. That way we can kind of account for the walls and use it as an outside rectangle. So we have this point, we're going to move it. Now we're going to move it both in the X by, like I said, 18 and up in the Y direction by 27. So instead of bringing both an X and a Y, we can use component of vector X, Y, Z. We won't be using Z because we don't need to go up. We'll be using the X and Y. And we can use now a slider for the X direction, which is going to be 18 feet. Here's the thing. Since this is in feet, and my drawing units are in inches, I actually have to do a conversion. So it has to be 18 times, so multiplication, 12, which means that we're multiplying 18 by 12, which is going to turn it into inches. If you're using meters, you kind of can skip this step. But this is going to be critical because, like I said, our drawing is going to be in inches. Then this makes it so 18 feet turns into 18 feet times 12, and we can move it using feet for the overall size. We'll do the same thing here. Slide it down, tap Alt, and we'll do the same thing for the Y direction. And we'll do here 27. So now that we have 2 points, we can use point A, which is the origin point, and then point B, which is this one, to create the overall size. Next, we need to create the offset for the wall. So depending on how this is going to be constructed, your wall thickness is going to be different. I'll plug in the rectangle into the offset curve input, and I'll go here to negative because we want to offset to the inside. And now we can use the slider. So let's go here to 5.500. But let's make the wall 8 inches. We can always change the size. So let's make this 19, or let's make this 20 here and make this 30, just to keep it an even number. So technically we have the inside wall, the outside wall, and now we need to focus on creating the wall for the closet, for the sink, the tub, and this is going to be for the shower and for the toilet. So let's go to this curve and we're going to explode it. Why? Because since we have this offset, these are all contained in one and it's a closed polyline. When you explode it, now we can use list item. And these are going to be 4 segments, which makes sense because that's the rectangle. Now we'll go to the first one. And it happens to be that the index of 0, you always start with 0. So index of 0 is going to be the one that we need. That makes it useful because now we don't need to plug in an index or change the index number. You can always go to plus to add other ones, but you can always subtract it and just use this one to offset by 8 feet. And for this one, we can actually use that same number of this because we're using this one to this one, and then we're going to go into the outside. So using this, we're going to offset. You can actually use this again because that's 8 inches, but actually no, we're going to use this one. We're going to use in feet. We're going to change this to 8. And now we're going to offset. So we'll just bring in a new offset component. And the distance is going to be 8. notice once again that it's offsetting in the wrong direction. So we can either change the slider to go to -8, or we can just bring in a negative component to offset in the opposite direction. Here's the thing, depending on, like I said earlier, how you construct this, you may have the interior walls be a different size than the exterior walls. So we can either use the exact same slider and plug in for this offset. So we're going to offset this curve again. So let's take this, slide it, tap Alt, because we know we need to bring it in the negative direction because that's how it offsets it this way. And we can use the 8 inches from here if we want to, or we can use a different slider like this one, and let's say make that 6 inches. So now that we have that, we now need to create this wall and this wall. So let's take a look at how this is constructed. So we have from this inside wall to this inside wall, we have 10.5 feet. So let's do that. Let's find out. Well, we can't use this line segment because this is a really long line segment, and we would want to use this line segment, the end point of it, with this point here. So how do we do that? Well, let's go to this curve. We're going to get the end point. And one of these is going to be the start, and one of these is going to be the end point. And we can find that by bringing in a point component, hiding this one, and then you plug this in here, and notice that the start point is actually in the opposite one, and the end point is the one that we want. Now, how do we get this point? Well, if we go back to the exploded one, notice that not only do we explode it relative to the segments, we also have the vertices, which are the points that create that line. So we can once again extract one of those points by bringing in a list item, and we can plug in the vertices into the list. And we're going to start here, and this is going to be the second one, if I'm not mistaken. So we can know that by clicking plus. Notice that we're getting the other one. Now we can just use this output, or we can subtract it, right click on index, and set this to 1. So this is useful because we're going to create a line segment starting at this point, ending at this point. So let's do that. And now when we offset, it's going to offset, if I'm not mistaken, to the right. So we need to offset it in the negative direction, but let's find out if that's the case. So we'll take this, slide it, tap Alt to create a copy. Why? Because we already have an offset using feet, and we might as well reuse it rather than having to recreate everything. So notice that by offsetting it in the negative direction by 8 times 12, which is going to be 96. Now we've created one of these walls. Now here's the thing. The way that this drawing is created, it's showing that from here to here is 10 feet, but it's a bit inefficient for our script for us to do that. I think a better way of doing that is going to be offsetting this part here, which is typically, the minimum is going to be 36 inches, because you can also put the toilet facing this way with the shower here. I think that might even be a better layout. But we'll go from here to here. We'll just make it 4 feet. So let's go to the script, change this to 4. And now we can offset it by the wall depth. So we notice that we did that here. So all we need to do is copy this offset because we've already done it rather than having to do it all over again. And if we want to keep the same, so this is not a different one than this one, we can just use this one. And if we want to, we'll leave that here as an option for it to be a separate size. Sometimes your plumbing walls might be a different size than your regular interior walls. So those are kind of different things on how they're going to be constructed. But the next thing we'll do is create this. Now, what's the size of this? Well, let's say this is going to be a vanity. We'll maybe make it 3 feet and 3 feet. We'll make this 6 feet between this and this, maybe even more. So what we need to do is take this line segment and offset it. So what's happening here is, notice that we can always change this. And if we offset this curve again to create that one, it's going to be dependent on where this wall is. Hopefully that makes sense. Otherwise, we can just take this line segment and offset it here for the 11 feet. So maybe let's do that. Let's take this one, copy it up, and offset it by 11. So basically taking that line that we created here and offsetting it by 11, and then offsetting it in this direction by the 6 again. So notice that this one was offset. Well, we can just do that one more time. So I'll slide it here, tap Alt, and do this one. So now this changes independent of this, rather than when I move this one. If I were to offset this one, then if I move this one, this one would change. So those are the things to keep in mind. And I have this wire coming all the way from here, all the way over here. We could leave it because it's kind of showing where it comes from. But sometimes I do like to hide the wire display because I don't want to cause too much clutter. And you can always see where that came from when you select it. So it's not like it's gone forever. Okay. So technically we have the layout created. All we need to do now is turn it into 3D. Now for this portion, there are different ways that we could do it. I am going to opt by creating this as a surface, this as a surface, that as a surface, and then joining it. For this, there are different techniques that you can use. I'm going to use loft to create that surface between these two and flatten the input. Then use that same loft, copy it, but just overwrite it with the other two. And now we can go back to this one and this one. So either bring in a new loft component. I just feel like it's more efficient just to copy this and overwrite it. But everyone has different ways of doing it. So just keep that in mind. So we have those walls. And then we're going to go to the original wall, which is this one and this one. And we're going to now create a boundary surface between those two. When you plug those in, you're going to see that it creates two surfaces, one for the outside, one for the inside. If we flatten it, you will fix that issue. And now we can use brep join to join the outside, the interior wall. Well, let's go to this one. Holding down shift, I'm adding another input. Holding down shift, another input. Holding down shift, another input. So technically now, well, with all of these that come from different places, I do, like I said earlier, hide the wire display. If we look at BREPs, it says one open BREP, which is good. That means that they all joined. Now we can take all of this stuff that we did back here and hide it. And lastly, you're going to see that this creates a crease, that creates a crease, and every time you join something, you're still going to have the location where they meet. They're technically put into one, but there's a crease. So to change that, we'll do merge all faces and then hide this one. So what's cool about this is now we can see the entire layout. And if this is 4, this is, let's say, 12. And we can change the overall size of the room if we want to. So this is what makes it useful. So let's go back to 20 by 30. Now what we'll do is take this and extrude it. So let's go to 3D. And this is going to be a typical extrusion. So extrude, and the direction is going to be up in the Z direction. Now we can use either inches or feet. Here's the thing. Typically when we do architecture, or at least from my experience, is your drawing is in inches. Why? Because the overall sizes are in feet, but the smaller, more finer detail is going to be in inches. So just keep that in mind. I'm just actually copying a lot of these feet to inches conversions, which is a slider multiplied by 12. And then here, the height, we'll do 10. So we have this layout. We're starting with the basics. The basics is going to be the overall layout. So when we look here at the layout, we have this entrance, we have this pocket door, we also have this pocket door for the bathrooms, and then we have the windows. In terms of it being efficient, I don't know if I like this door being so small. I do like the fact that you can close that, and that you have a little bit more room for the kitchenette. So obviously this layout may not be exactly what you want. So what's cool is that you can always change it to be whatever you want. So starting here, let's explore how to do this portion, because I'm trying to think what's going to be the most efficient way. Let's start with the doors. So the entry door. So if we go to the script, we see that this entire surface, or this is an extrusion. So let's actually hide this and bring this back. What we need to do is get the midpoint of this. We also need to get the midpoint of this and the midpoint of that to create the doors. So I'm trying to think here. What's the most efficient way? Well, here's one way that's coming to mind is deconstruct BREP. Now, to figure out how all of these line segments are organized, we can get the midpoint of these edges. The reason why we do that is so we can use a point list and figure out how all of these points are organized and how we can use those points. And I'll show you that. That'll make more sense in a second. So let's go here to change the size. The size parameter is already here, but we can't really see it. Let's change it to this. So to create the door, we need to move this 4, this point 4 in the negative y direction, the same as the depth of the wall. For this one, we can use 16 and 17 to create a line segment and then offset it relative to the center. Same with this one. And so using these points and knowing how they're organized relative to the way that we exploded it is going to help us recreate this design. So let's go to this one. It's going to be in the middle by 36 inches. So we need to pick this midpoint. It's going to be 0.4, or let's do it more like this. This edge 4, we'll go to list item, and we'll go here to index, set integer 4, which is going to correlate with this number. Now, we can take this and offset it, or we can get the midpoint and move it in the negative y direction. So unit y, negative. And use the slider that we had for the outside wall. So let's go here to this one. Remember, that's the same offset as, actually, it's not this one. This one. That's the same offset as the outside wall. So this is what we want to use to move that point. Why? Because now we can use these 2 points to create a line segment between the start point, the end point, and we can offset this using inches by 36.000. And then the same thing in the negative direction by 36. And I did this to show you that if we offset this way by 36 and this way by 36, it's not going to be 36, it's going to be more. So let's say we had 24 to this side, 24 to this side, it's going to be 48. So technically we need to double click here to create a relay that goes to both, and then go here to divide by 2. And the reason I use the relay is because this is going here, this is going here, and we want to just divide this number by 2 and then override that input. Now we can use 36, knowing that it's a true 36 inches relative to that center line. So let's hide this portion, which is what we had before. In between these 2 lines, we can loft them again to create a surface. And then if we go here in 3D, go back to this 3D portion, we can extrude this surface I'll copy this and use the height of 8 to create that. Now we're not going to subtract it yet because we want to do that once we have all of the solids intersecting. But for now, just wanted to show you that process because technically we'll be doing the exact same thing to the rest. And so a lot of these steps here are going to be copied to those locations. So let's do that. Let's go back to this, hide it, take this one, We'll hide it. Let's go back to the top view. Between 16 and 17. So let's go here where we pick this one. Now we're going to copy this and we're going to create 2 line segments. We're going to go to 16 and then 7. If we click plus, it's going to be the next one. So it's going to be 17. So now we can get the midpoint between those 2. And since we know that if we have all of this, again, basically we're copying the steps, and because we've already created it here. So if we have the start and end point, that's going to create this line segment. So let's just keep that in mind. This part gets a little bit confusing if you haven't done it before. So just giving you a heads up. Start and end point, we'll copy that one. We'll copy all these, unless these doors end up being the same size as the door here. You do want to be able to control them independently. And then the door height, the interior doors sometimes might be smaller than the main entry door. So we'll copy the slider as well. But let's say that we're the same size. You would copy all of this except for the sliders. So those sliders then control the copy. So we'll take this, slide it up here, tap Alt, and oh, I missed one of these. So I missed the start and end point. So this one, we'll take it, slide it up, tap Alt, put it over here lined up. And this is sometimes what adds complexity to a script. It's not necessarily new stuff. It's just copies of the same stuff that you had before. So we'll use this as the start point, this as the end point. And notice that we've already created this door. Now we're going to do the same thing with 18 and 19. So let's take this, slide it down, take this. Technically, we can copy all of this, slide it up, tap Alt. Those are going to be the same size. So actually for this one, this is a good example. We'll copy everything except for the sliders. And notice that the sliders then control both of these. And I'm going to move this up a little bit. Now it's 18 and 19. So all I need to go is go to index, go to 18. And it creates that door there. So let's go back. Let's go to this door, which is not, well, depending on how you want to create it. You may want to just create an opening here. But the idea is that we use 15. This is going to be different than these because these are relative to the center point, so they're basically the same thing. We're going to take this, or let's just do a new one. List item. We'll use this edges for the input because we want to pick one of the edges. Is going to be edge 15. So if we go to index 15, let's do that again. 15. We're going to get the endpoint. One of these is the endpoint, so I'll hide this and use a point component and plug it in here. And so the endpoint of it, we want to move up in the Y direction. So kind of have this, but let's do it different. Y direction, move, and tie it to the wall depth that is made for this one. So what is that? Well, we know we have all of the parameters here. We just have to make sure to go back and pick the correct one. So this is 8 inches to the inside. This is what creates this one. And this is what creates that other offset. So we know that this number here, 6, is going to be the offset or the move point. So now we have this one and this one, which creates a line segment. And since this is not a center line, we technically can't offset to one side and the other. It's actually a little bit easier because all we need to do is move it in the negative x direction. So move this line segment, negative x direction, and we'll use a slider, we'll say 36. And now we can create a loft between those two. So this controls that overall opening. So if you want it to be a door, if you want it to be just a larger opening, this is what controls that. And now the extrude for this may be independent of these two, because these two, it makes sense for them to be the same, but this one might be a separate one. So let's do that. Let's take this, the extrude in the Z direction, all of this. Why? Because we've already created it, so why have to bring in other components if we've already done it? So let's bring back all of this, basically turn on to view all the extruded doors and bring back the walls. But notice it starts getting a little bit messy, but you can still see how everything is still organized. So I like to keep things clean. I mean, it's not necessary because what matters is that you know how things plug in. I just feel like, I don't know, I'm just used to it, I guess. So let's hide the wire display here. Hide it. And we have all of these 3D doors, and we have the overall wall. All right, so we have that for the most part. We can almost already subtract from it. Oh, here's one thing to keep in mind. I can't believe I almost forgot. These doors are not centered. They are relative to where the sink is. So if this is like a 2-foot vanity or an 18-inch vanity, that is where the door is located. Technically, you don't want to go that close to where the vanity is because you typically have some trim around the door. So these doors, this one and this one, want to be able to be shifted in the negative Y direction. So let's move in the negative Y direction. Actually do it like this. Here's the thing. It does sometimes matter where you put the negative, whether you put it before or after, because if you put it after, then you can still use this vector as a positive and then this one as a negative, where if you put it before, you can only use this output as a negative. So, and sometimes I kind of mess that up, so just keep that in mind. And then here we can shift, let's say by 12 inches. And then hide this one because that is the old one. And hide this because that's kind of the old location. So we can do that for both of these. And these lines. And you can also leave it at 0, like it could still be centered. So let's take this and just copy it down because we want to do the same thing to this one. So these two get shifted, and let's hide the stuff that we did before. So let's go to 3D view and I'll show you kind of what that does. So we have this shifted by 0, or you can shift it over this way or shift it, well, you can also shift it the other way if you use a -100 to +100. And then use this as old. All right, so at this stage, actually, it's a really good idea to just save this. So I want to do this in parts. I think this is going to be a great tutorial just to get started. A lot of the other steps are going to be very similar for the windows and stuff. But let's pause here, and then I'm going to pick this up and finish it off in a different video. Let me know if you have any questions, if you got stuck somewhere. I'm going to have this available on my website. So thank you very much for watching. Now let's go back here and let's save it. So let's go document save. And save this into your folders here. So I have a folder system where I have a file save. Let's go file. And then we'll call this Parametric Hotel Unit Script. And then _1, because this is part 1. Okay. Actually, no, let's not finish yet. Let's do the subtraction so we can see it better. Okay, so I lied to you. We're going to subtract from it. So using a difference or Boolean solid difference, that's how it's called here. So using the walls as BREPS A, which is what we want to keep, and BREPS B is going to be what we want to subtract. So starting with this one, and I hid the other one because now we're going to see the leftover wall after we subtract these. And we have to flatten the input so it looks at all of these new inputs as one list. So plug that in. We'll plug this in, holding down Shift once again, and then this one again. Now all of these coming into here, I do hide this. Just we don't necessarily need to. But we know that this is the result of all of that. And now we can hide basically everything. And we can look around and we can move some of the sliders. So let's say this one, oh, I want that door opening to be larger. I don't want to have, well, you need to have a closet here. So we can just say 48. And, oh, we want the size of the room to be larger. So we can increase this. So the entry is going to get larger. And then if we want, let's say we go over here, we want that entry to be even deeper. We can do that. This is going to be the size of the interior walls. So that's going to determine something. And then we go back here and change the size of that intermediate bathroom. And then this one changes that size of that the powder room or where the toilet is. And yeah, the size of the height. So we have that, the extrusion portion. And then the shift towards the end, well, the size of the doors here. So 36. And then if it's shifted or not. So if this is -7, we can do 0. We can shift either way. And at the end, we have this solid that I do like to use a custom preview and a color swatch. And then use maybe a darker gray here so we can visualize the overall design. So starting with this simple outer wall, then moving and offsetting the interior walls, and then using the way that that was organized to extract the midpoints to then create the solids that then would be subtracted from the overall wall. So that is the idea for creating floor plans. This is a pretty straightforward process. It just requires a lot of steps to create it. But at the end, you have the power of reusing this script and this layout in so many different configurations depending on what needs you have. So this one is going to be a 20 by 30. You can change it to be a smaller size. So let's say you didn't want a tub, but you just want one sink. Well, you could do that. All we need to do is change the sliders. So for now, let's change the labels here. This is going to be X. This is going to be Y. I'm going to group this and group this, so we know that those are the sliders that we can change. This is going to be the exterior wall. This is going to be the bathroom Y. And this is going to be the interior wall. This is going to be this size. So this is going to be bath wall 1. It's going to be bath wall 2. And obviously these can be labeled whatever you want. So this is just kind of what I'm used to labeling them. This is going to be the wall height. This is going to be point list, so it doesn't really matter. This controls how we see the number size, so it doesn't really matter. So I don't group that one. Then over here, we're going to go to door size 1. This is going to be door height 1. You can call it entry door if we want to. It's going to be bath door height. Bath door width. This one was the entry, what do we call this? Tall opening. This is going to be door height, hall door height. Because this can technically be like a full height opening if we want to. So if we did 10, it would kind of match the overall height, or 9. To still be able to have a structural beam there. Let's group that. And at the end we have this, which sometimes I like to route it through a geometry component here. So there's still more work to be done to create the windows. But overall, this shows you the steps and what we're able to create here within this script. Now, this seems a little bit crazy, but like I said, a lot of these steps are just copied over and over again. And what was a little bit trickier at the beginning was to figure out the layout. And from there, it's just extracting what you've already done to finalize your work. So thank you very much for being here. I know I almost finished the video earlier, but I just wanted to show you from the beginning to the end. This was my first time giving this layout a shot, and I think it went pretty good. So let me know what you think in the comments below, and I hope to see you in the next one. I'm actually going to take this and put it into a rendering program that I use that it has AI. And a lot of people are kind of against it, but I feel like it is very efficient in doing it with the time that I have, and it creates some pretty good results. So stay tuned for that. So I've been using ReRenderai to visualize the designs that I create within Grasshopper. So I bake the geometry, bring in a capture, and I've had a few different options here. I think this is one I like the best just because this tutorial is nothing for creating something final. It's just the beginning, and I'm going to be doing more parts, but this kind of shows it in like a setting that I was thinking more of like a resort, tropical kind of area. So if you want to see how this works, all you need to do is go to ReRenderai.com, and you'll see that you can use some of the codes that I have down below, and you'll be able to see, look at all the different things that some people come up with. It's really good for visualizing your designs. So I would, if I were you, I would consider checking this out. So thank you very much for being here, and I hope to see you in the next one.